Hi, I'm Michael Breen with EV West.
And I'm Matt Hauber.
Today we're going to talk a little bit about the drivetrain in our BMW M3. We get a lot of inquiries about this car ever since we set a record last year for the street legal electric class at Pikes Peak. And it's the same car that's in the famous video with Bill Caswell, and the big old EV grin. So a lot of people wonder, what's involved in making a system like this. It's pretty simple. It's two net gain 11-inch motors hooked up to a Powerglide 2-speed transmission without a torque converter. So it's a direct drive system. It's pretty unique. We're going to go through step by step. Matt's going to show you how to put the motors together and couple them and then hook them up to the Powerglide transmission. So we're just going to show you how to do this, and hopefully you can put one of these in your own project.
Yep.
All right, let's get started.
All right. So one of the first things that we need to do here is we need to cut these shafts down. They come pretty standard universal. They're about 3-4 inches long. Here at EV West, we really like to make everything as compact as possible. So we actually have our inner motor flanges down to 3 inches. So what that's going to mean is we need to cut these motor shafts down to just a little less than 1.5 inches each. And then we can couple these together. All right, so I have my calipers set at 1.5 inches, and what I'm going to use is a 12-volt battery to spin the motor shaft as I mark it with my permanent marker. All right, now that our motor is marked, what we're going to do is use the same 12-volt battery, and we're going to spin the shaft while we cut it. And what that's going to do is it's going to ensure a true cut all the way through. I'm just going to use a regular old 4-inch cutoff wheel. You can get these at Home Depot, anything like that. Let's go ahead and do it. Okay. Well, as you can see at the end, I took the tool and just kind of ground over the end and over the edge of the splines, and that's to knock down any kind of burrs or anything like that that would hinder the coupler to slide onto there. All right, so we're finished with the first motor. Let's go ahead and do the same thing with the second one. What you're going to want to do is it is 1.5 inches from this face here out, or you can do 1 inch from this step here, which is already 1/2 inch out. Let's go ahead and set this up here. Okay, now our mark is set. Let's go ahead and cut it off. All right, so we have our 2 motor shafts cut down here now. Let's go ahead and put the coupler in between the two and push them together and make sure that our distance between here is a little less than 3 inches, maybe 20 thousandths under. There we go. Okay. Now we'll just check our distance. All right, so I checked the distances between the two now, and we're just under 3 inches, so we're good to go. What I'm going to go ahead and do now is I'm going to pull the motors back apart, and I'm going to put this flange on this motor, this one on this one. You bolt the flanges to the motor first, and then you bolt the 2 flanges together. So let's go ahead and do that. A little bit of a bear sometimes lining these splines up. There it goes. Then you just match these holes up here with the studs through the flange, and it literally bolts together just like that. So now that we have our 2 motors coupled together, let's spend some time talking about our Powerglide here. Original Powerglide will come with an input shaft similar to this. This is how much sticks out of the front pump housing. So there are options out there that you can buy right off the shelf similar to this that basically allow you to eliminate the torque converter. But as you can tell, that much hanging out of the pump, we're looking at about an 8-inch adapter, and that just doesn't work for most projects. We've already got a pretty long motor here. We've got to find a way to get these things tightened up. So that's when we came up with this. This is our custom input shaft here, and this is a female Turbo 400 spline that literally will bolt right on the back of a Warp 11, Warp 9, anything with the Turbo 400 output shaft. Now, because of the fact that we're not running a torque converter, we actually have to supply oil when these motors aren't spinning. We actually have to supply oil pressure to keep the clutches engaged. And that's where this comes in. This fitting right here on the outside is where our electric pump gets, where the pressure gets put in. Goes in through here, there's a one-way check valve, goes through this line, and it goes right into the front pump. Feeds pressure just like the transmission is used to seeing. All right, well, before we get this thing mounted up, I just kind of want to talk about the splines, the reason why we did a splined coupler instead of a keyed shaft. One of the reasons is, not having a set screw pushing down on a keyway and being able to get to that. None of that seems to really work out well. This transmission, I can literally grab a hold of it and I'll just slide it right on the splines, I'll bolt it in, and the thing is completely done. So let's go ahead and do that. All right, so we have the two motors bolted together now, and we also have the Powerglide bolted to the last motor. We should probably talk a little bit about the hydraulic system in this. Now, we don't run a torque converter with this Powerglide, so basically what we have to do is when the motors are not turning, we actually have to supply hydraulic pressure with this pump to keep the clutches engaged. So literally it comes with good mounts for it. It comes with a rubber perch as well, it keeps it real quiet. We also supply a few other things. There's some fittings here, hose, relays, wiring, everything you're going to need to do that. We recommend probably using number 6 fittings, just for running the plumbing on this. Also, we tried a lot of different things, pressure and everything else, but what ended up working out best for us is an RPM window switch. And what this actually does is anything below 500 RPM actually turns the pump on to keep all the clutches applied. After 500 RPM is reached, this will shut the electric pump off, and the internal pump will take over, and you're rolling away. We have two 11s, which I'm sure you guys know by now. They're capable of doing 1,000 to 1,200 foot-pounds of torque between the two of them, and you can expect anywhere from 400 to 600 horsepower depending on voltage sag. Overall length of the whole package is 54 inches. And on the back of it here, obviously we have our 2-speed Powerglide set up. You can get this in a 1:7:6 ratio first or a 1:8:2. And then second gear is direct, so just your 1-to-1 straight through. Yeah, some of the great features as well with this is it is more than capable of handling any kind of torque that these two motors can put out to it. But it also has park. Park is really important with electric cars. These motors freewheel, and if you just rely on your engine holdback like you would on a gas engine, it'll just roll down the hill. So great park. You can use your e-brake as well as a backup. I think that's a good idea. It does have reverse, which is another big deal with DC motors. There's a lot entailed in basically reversing contactors and stuff to get the motors to spin in reverse. So having a transmission that has reverse drastically simplifies the conversion. So. Yeah, I think that about wraps it up, man. You guys, any questions, please give us an email, give us a call, whatever. We'd love to help you out. Matt Hauber, thank you. God damn. Man, I need a break. I'm not getting.
Shooter McGavin.
Oh. I keep, hold on, let's just hold on. Let me get situated. All right.